Welcome everyone to another video exploring the use of YouTube pedagogy in the classroom. My name is Ryan Duckett and I work with Acumen Research and Evaluation, and we provided statistical analysis and formative evaluation for a large-scale research project that explored the use of YouTube problems in the engineering classroom. Another video in this series introduced a way to quantify engineering problem solving using a rubric called process. This video discusses a situation that occurs both in education research as well as when teaching large classes. Hundreds or even thousands of problems require grading, so multiple faculty, teaching assistants, or other graders may divide up this time-consuming task. Having an easy-to-use rubric like the process is just the first step to getting agreement between different graders or raters. In this video, I describe one such situation encountered during our YouTube problem research project. For this example, 4 qualified raters made up of professors, students, and teachers were faced with the task of scoring over 2,000 unique student solutions to YouTube problems over the course of one semester in a material and energy balances course in chemical engineering. While adding additional raters helps reduce the grading time commitment, greater variability can occur as individual raters could interpret and apply the rubric differently. Let's consider scoring a single YouTube problem using the process rubric. A well-designed YouTube problem requires students to exhibit a mastery of fundamental chemical engineering concepts. For multi-step problems such as this, a simple correct-incorrect scoring format does not capture the range of problem-solving abilities. The process rubric has 6 items that are graded when students submit a solution. This rubric assesses how well students complete several components of problem solving that are integral to solving chemical engineering problems. A successful answer will adequately provide problem definition, represent the problem, adequately organize information, perform the calculations, show that the solution is complete, and that the solution is accurate. As seen here, a 4-point rating scale is used to score how well the student performed on each of the 6 items on the process rubric. Here, we see the scoring guide for the R item, representing the problem. Notice how this rubric provides a brief description of the characteristics of an answer for each score or category. This is important, ensuring that raters use the categories in a consistent way. It is important that every rater understands what each rating category represents for each item when grading a response. Here, we discuss a few steps you can take to reduce the extraneous sources of error that using multiple raters can introduce. The goal is to ensure that all the raters score the answers consistently so that the differences in student performance can be attributed to different ability levels of engineering problem solving and not a result of receiving a rating from a more or less severe rater. But even with a well-designed instrument with definitions for each scoring category, there will inevitably be variation in how multiple raters score a given problem. Now, we will look at an example from our research that shows how using multiple raters can introduce discrepancies in reporting student ability. This figure displays the process score given to 6 different students, represented by A through F on the x-axis, by the 4 raters, represented by the different colored shapes. The range for possible scores on YouTube problems scored using the process rubric is 0 for a submission that got nothing correct, up to 18 for a perfect solution. Notice the difference in score student B received from the 4 raters. That student would have been very disappointed if rater 2 was the grader they received. Similarly, student C would have been quite pleased if rater 3 was their assigned grader. The discrepancies between scores pose a problem for accurately grading the student's YouTube problem solutions. Therefore, it is important early on in your grading to take a few steps to ensure that raters are using the process rubric consistently. After your graders have scored several of the same student solutions, have a meeting to discuss differences in scores. The figure we see here is an example of the process item scores that the 4 raters gave to one student's homework submission. This case shows a large amount of agreement. Someone facilitating this meeting would ask rater 3 for an explanation of the score they provided for the solution accuracy. Did they understand the categories differently? New users of the process tool may require a little extra training in recognizing when an answer deserves each of the possibilities for the scores on a process item. Here, on the other hand, we see several areas of disagreement between the different graders. The source of the different scores, be it different interpretation of the answers, uncertain about the differences between, say, a score of a 1 or a 2, can be explored in a meeting with the graders. Such a meeting allows everyone to get on the same page and use the process rubric in the same manner. This will help ensure that the scores being given to students are consistent and reflective of their problem solving ability rather than a result of which grader they had. Throughout the grading process, you can also generate a statistic that tells you the amount of agreement you have between your raters. Here, we can see the intraclass correlation coefficient that was computed during the research project. This served as an indicator of how consistently the different raters graded the same set of student solutions to the YouTube problems. The scores provided by the raters before the reflective grading meeting indicated a moderate level of agreement and a lack of confidence in how similar the four raters were grading the same solutions. After the meeting, though, we can see that there was an increase in the consistency with which raters used the process rubric to score students' answers. As a result of these simple steps that were undertaken early and throughout the grading process, we were able to implement multiple raters to help distribute the considerable task of grading thousands of student solutions. Further, we could demonstrate that the scores the students received were truly reflective of their chemical engineering knowledge and problem-solving ability. Be sure to watch the other videos in the series that take a deeper look into how we use the process rubric to measure problem solving, as well as the various ways YouTube problems can be integrated into your curriculum.